Whereas you need to go to the website a+students.com. Once you're on the website, you select math as your subject. This is a grade 9 math lesson, and the name of the topic is statistics. The chapter number is 9 and the lesson number is 10. And the name of the topic is analyze a regression line of the data set. So some information would be given to us and we'll try to create a regression line and assess what the regression line is, the information from the regression line, okay? So the question number 1 says, I'll just copy the question. And they are saying, if this information has been provided to us, we need to find the regression line such that this is the information that has been provided to us. And the question says, use the least square regression line of this data set to predict a value. A sporting goods chain is planning to open a new store in Grant County. In order to decide on an optimal location, their market research gathered the data on sports facilities in towns across the county. The data in the grid gives us the information. What is it saying? The population. It gives us the population in thousands. Okay. And the sports facilities that are available. For 33,000, one availability, 34,000, three availabilities, and so on, right? We have the least square regression line. We have this equation given to us. Okay. And they're asking how many sports facilities does this line predict for a town with 42,000 people in it? Okay. We know for a straight line, linear, the equation of a line is always y is equals to mx plus c, where m represents the gradient or the slope, and the formula for the slope is y2 minus y1 upon x2 minus x1. That is basically the change in the vertical axis upon the change in the horizontal axis. And c represents the y-intercept. That means where the line will cut or intersect the y-axis, the horizontal axis, okay? So we need to find how many sports facilities does this line predict for a town for 42,000 people, okay? What we can do is we can substitute, because this is the value of people, right? This represents the value of x, and these were the values of y. So what we can do is we can simply substitute the values of x into the equation and we can find the approximate value of y, okay? What we can do is, if we had the equation y is equals to 0.237, that is a slope, we put the value of x minus the intercept, that was 6.599. This was the equation that is already given to us that represents the regression line. We substitute 42 over here. Okay. Once we multiply these values, it comes out to be, let me do the multiplication, 0.237 into 42 comes out to be 9.954 minus 6.599, and the final answer for y comes out to be 3.355. We cannot have 3.55 sports facilities, right? Therefore, it's rounded off to this lower bound and it becomes 3. Okay? Either they can have 3 facilities or they can have 4 facilities, right? Okay. So what we can say is it predicts that there are approximately 3 sports facilities for a town with 42,000 people. Okay, this was a prediction that we had to do. We had to predict a value and we had to tell exactly, like, if these were the people, how many facilities were there according to this line. Okay, according to the information that was provided to us. Do we agree? And any questions up till now? Okay, good. Let's move on to the next question. Let's example and see what needs to be done here. For the next question, it says, use the least square regression method, okay, to find the data from. Okay. Question number 2. The second question has this information for us. We'll use the same method to simplify question number 2. It says, use the least square regression line for the data set to predict a value such that Matt wants to ensure the new board games he's designing accessible to a wide range of different age groups, right? So he has age, that is the value of x. The number of games won would represent the vertical axis. Okay? The equation has been provided to us. The equation given in this question is this, where this is the gradient and this is the slope. That means it has a negative slope. Okay, one more thing to remember. If we have an axis, just giving you this as an example, this was the vertical axis, this is the horizontal axis. I'm just telling you, just by looking at the equation, we can tell what the shape of the line should be. If the line is increasing, right, that means the slope is positive. If the line is increasing, the slope is positive. If the line is decreasing, the slope will always be negative. So since the slope over here, the gradient is positive, right? That means the line will be increasing. Okay. For this given information, what they're saying is the least square data for the regression set for this given equation, we need to find how many games does the line predict would have been won by a 12-year-old. For a child that has an age of 12, we can copy the 0.368 x minus 2.432. Since x, this represents the value of x, we substitute 12 over here. 0.386 multiplied by 12 comes out to be 4.632 minus 2.432. It comes out to be the value of y comes out to be 2.2. But no one can win 2.2 games, right? They have to win either 2 games or 3 games. Therefore, this is rounded down and it comes out to be 2 games. So what we can predict is the, the line predicts, the regression line predicts that a 12-year-old will win 2 games. Agreed? Do we agree on this? So we have to find the prediction for this. Let's move ahead. Let's see what question number 3 has for us. Are there any questions up till now? If there are any questions, do let me know. For the next question, it says, use the least square regression line to predict the data in the given data set. Okay. Question number 3. Just telling us to use the least square regression data line to predict the values. A team of forestry specialists from the Henderson Lumber Company visited a section of the forest that was going to be logged for timber. They took measurements to evaluate the health and growth of the trees in the area. So the X represents the age of the tree and Y represents the diameter, the thickness. Okay, diameter would be thickness. Okay, so the equation for the d-square regression is given to us, and this represents this information where the slope is given as this and the intercept is given as this with the values of y and x over here. Okay, so they're asking us what does the line predict the diameter of a 41-year-old tree would be. It says 41-year-old. That means it represents the age, and age is represented by x. We have the equation 0.021, the value of x plus 0.619. We simply substitute the value of x, that was 41. When we multiply, 41 is to be multiplied 0.021. It comes out to be 0.861 plus 0.619. And the answer comes out to be 1.48. Agreed? Okay. And they are asking us, just a new statement, round your answers to the nearest thousandth th. Okay. This was given to us in the question. They were asking us to round our answers to the nearest thousandth of a value. So thousand mean 3 decimal places. Agreed? Because we have, I'll explain over here, we have the decimal, we have the ones, we have the tens, we have the hundreds. Sorry, my mistake. I'm making, I made the decimal early. Just a moment, please. Okay, if we have the decimal place, okay, we have the tens, we have the hundreds, right? And then we have the thousand ending with THS. This was ones, this was tens, this was hundreds, and this was thousands. Thousand. The difference is these numbers are ending with THS. The numbers ending with THS are after the decimal. That means we need to give 3 decimal places. The answer came out to be 1.48. That rounds off to 1.480 because the answer had to be given to the rounded off to the nearest thousandth value. So what is the prediction? The prediction is that the tree would be a 41-year-old tree would be, just a minute, a 41-year-old tree will have a diameter of 1.480 meters. Agreed? So we need to do the prediction from this given line, where the slope, that is the gradient, and the intercept has already been provided to us. Any questions till now? Okay. If there are no questions, we'll move on to the next question. The next question says, use the least regression line of the data set to predict your answer to the nearest integer. Round your answers to the nearest integer. Let's see, question number 4. If this is the information that has been provided to us, we need to find the answer to the nearest. Okay, this is our question number 4. Use the least square regression line to predict a value such that NG notices that everyone in her class reads at a very different speed. Reading speed, right? She wonders if a person reading speed is related to the number of books he or she reads. So book read last month represents the value of X. The second column, that is seconds needed to read the paragraph, the time required. Seconds is basically the time. Okay, so 4 books, 1 para took. Someone who read 4 books last month took 80 seconds to read a para. Someone who wrote 6 books took 91 minutes, right? So the equation for the least line of regression is given to us. Okay, this has a negative slope. I'll rewrite this, sorry. Rewrite the equation. Okay, and the equation given was y is equals to minus 10.318 x plus 136.636. Okay, and what do we need to find? How many seconds does this line predict it would take to read a paragraph for a student who read 5 books? That means the value of X is given because X represents the books. So when we simplify minus 10.318 318 multiplied by 5, it comes out to be negative 51.59 plus 136.636. And the final answer comes out to be y is equals to 85.046 sec. We cannot do 0.46, right? And we had to round this answer to the nearest integer. Integer means whole number. That means a final answer would be 85 seconds. Okay, so the prediction for this is, what will be the prediction? A student who read 5 books last month would take 85 seconds to read a paragraph. Basically, what we are doing is we are comparing the value of x against the value of y. Okay, so this is the prediction that we are making through this given information. For the next question, it says, just a moment please, use your least square regression to predict a value for the given information. And the given information to us is, okay, question number 5. If this information is given to us in question number 5, and they are saying round your answer to the nearest integer. This was question number 5. Use the least square regression line to predict a value such that a food scientist wants to understand how much sugar children like in their desserts. So X represents the sugar, and what did the scientist do? Sweetness and rate each up to 1:10, where 10 is the excellent sweet, right? So these were the, Y represents the ratings of the sweetness. The equation has been provided to us. The equation says y is equals to 0.187x minus 2.051, where this represents the slope and this represents the intercept. We have been asked to find what rating does the line predict for a pudding cup with 20 grams of sugar. So what we do is, grams is the value of x. So what we would do is, we would simply substitute the value of x into this. And what we can say is, for 20 grams, we substitute 20 over here, and the value of y will come out to be y. When we multiply 0.187 is multiplied by 20, it comes out to be 3.74 minus 2.051. The final answer comes out to be 1.689. We have to round our answer to the nearest integer. Okay, let's try to recall how do we round down and how do we round up. Okay, we know that if we have the numbers 0, 1, 2, 3, and 4, at the end we round down. And if the number is ending with a 5, 6, 7, 8, and 9, we do the round up. So keeping this information in mind, let's look at this number. This was a 9, round up. This was a number, round up. This becomes 7, right? This becomes, okay, I'll do step by step. 1, 6, 9 round ups, 169. This would round up, it becomes 1.7. We have to give the answer to the nearest integer. Integer means whole number. This would round up. That means y would come out to be 2. Okay. So what we can say, the prediction for this statement would be students will rate a pudding with rate. Okay, sorry. Rate 2 to a pudding with 20 grams of sugar. Okay. Sometimes it can be the other way around as well. Let's try to make another question out of this. Let's create another question. In part B, what the question is saying is, if students rated the pudding 4, what is the predicted amount of sugar in it, right? So now what is happening? They have given us the rating. That means the value of y is given to us. We need to find the value of x. Since the equation given to us was y is equals to 0.187x minus 2.051. The value of y was provided. We substitute this by 4. That means 0.187x minus 2.051. We can add 2.051 on either sides. This cancels out. This becomes 6.051 is equals to 0.187x. Once we divide, we can say the value of x would come out to be 6.051 divided by 0.187. 6.051 when divided by 0.187, it comes out to be 32.35 grams, right? And let's suppose we need to round our answer to the nearest integer. Okay, let's round our answer to the nearest integer. That would mean x comes out to be 32 grams. Okay, for if 32 grams of sugar were added to a pudding, the students, it's a prediction that the students would rate it for, right? Just a prediction. Okay, so we put another, this was, see, usually what we are doing in the question is that we were given the value of x, the grams of sugar, we found the rating, but we changed the question. We changed the question such that the rating was given to us, okay, and we found the value of x, okay. Okay. Okay, let's try the next question. For the next question, it says, okay, let's find, okay, question number 6. This is our question number 6. 1 minute, please. Let me realign. Question number 6 says, we need to find the least square regression line for the data set to predict a value, in which it says Mimi manages to the student health services department at Princeton School. She says students' poor breakfast habits are contributing to the school's academic decline. She also checks each student's GPA. So the breakfast is what they're eating is on X axis and the score is on the Y axis, right? The line is given to us, the equation given to us is 0.33x plus 2.605. Agreed? And what they're asking us, what GPA does this line predict for a student who ate breakfast 4 times this past month? And we need to round off our answer to the nearest 1,000. That means third decimal place. If the equation given was, we know that the slope is this and the intercept is this. So we can say for the given equation, 0.33 x plus 2.605, right? 4 times. They're saying a student who ate breakfast 4 times. So we simply, because breakfast is represented by the value of x, right? So what we can say is 0.33 times 4. 0.33 times 4 would be 1.32. 1.32 plus 2.605 would be 3.9, 3.925. We have to give the answer to the nearest 1,000, right? Okay. Let's multiply it again. 0.33 multiplied by 4, that is 1.32, okay, plus 2.605, I'm just confirming, 3.925, right? So that means the answer is already rounded off to the nearest 1,000. So this is our answer. And the prediction would be a student who had breakfast 4 times this past month will have a GPA, grade point average, of 3.925. Okay. I don't think so. Why are they? Okay. 0.33. I'll just confirm because it shows the difference answer plus 2.605. Ours answer is perfect, 3.925, right? Okay. Or there must be a negative sign. Let me see. 0.33 into 4 multiplied by -1 plus 2.605. Okay. Okay, my mistake. Okay, I'll show you the mistake. This is This is my writing error, right? Sorry, apologies for this. There were 3 decimal places over here. This is 0.033, right? 0.033 into 4 plus 2.605. Sorry, it comes out to be 2.737, right? We missed this 0. GP of 2.737. Agreed? Okay. It's better to cross check always, right? Moving ahead for the next question, let's see what is the prediction. The next question says we need to give our answer and round it off to the nearest integer such that question number 7. Question number 7, it says use the least square regression to predict a value such that for a final project in a political science class, okay, she's doing the initial approval ratings were labeled as X, final approval ratings were related with Y. The equation given to us was Y is equals to 1.534X minus 31.808, where the slope is given as this and the intercept is given as this. What they're asking us is what is the final approval rating? Final approval rating represents the value of Y. For this line, for Mayer, whose initial the value of X is provided to us was 67%. Writing down the equation, 1.534, the value of X minus 31.808. We simply put the initial, that was 67%. 67 into 1.534, that comes out to be 102.778 minus 31.808. And the final answer comes out to be 70.970. Okay, 70.97. What we need to do is we need to round your answers to the nearest integer. And we know that this would round up and round up. That means 71. Okay. So the prediction would be a student with 67% initial approval will have a 71% chance of final approval. Okay, do we agree on this? Perfect. Let's move ahead. Let's try a question from the test. Let's see what we can do in the test. Just a moment, I need to go to grade 9, chapter number 9. Sorry, chapter number 9. That was chapter number 9, lesson number 10. And the test we have, it says, let's do at least a question or two so that we have an idea what kind of questions can be there. For the test, the first question says, very similar to a question with a different value. It says, a team of forestry is finding the age versus the diameter. They're using the age, the value of X, against the diameter, that is the value of Y. we need to round our answers to the nearest thousandth, th, right? Three decimal places, where y was equals to 0.021x plus 0.619. X is the age in years, y is the diameter in meters. So let's substitute the value of x. Can I have the answer from someone else? 0.619. And what they're asking us is for a 41-year-old tree. So we can say 0.021 into 41 plus 0.619. 0.021 into 41 plus 0.619, and it comes out to be 1.48. But this is not rounded off to the thousandth, right? It's not rounded off to the thousandth. What will happen over here is we round it off to the thousandth and we write a zero at the end, because thousand means third decimal place, because this ends at th. So third decimal place. Okay. For the next question, let's see what are the possibilities. Okay, they already gave us the two options. We had to select one of the options, and the answer would be, sorry, I did not copy the options. These were the two options given to us. So obviously 1.8, 1.480 is the correct option. Okay, let's move to the next question. Another question says that age and games won. They're comparing the age of the children versus the games won. What is the predictive winning score? For question number 2, we have this information. It says Matt wants to ensure that the new board game he's designing accessible to wide age range of students. The age is represented by X, the games one are represented by Y. The equation that is given to us is 0.368x minus 2.432, where this is the slope and this is the negative intercept. What we need to find is nearest integer such that how many games does the line predict would have been won by a 12-year-old child. And the two options given to us are 2 and 3. I'll just simply copy the options. The 12-year-old can either win 2 games or 3 games. One of these two options. Sorry. Okay. Let's see what is the possible answer. 2 games or 3 games. Let's see. Can I have the answer to this? In case when the options are already given to us, right? We can do the reverse method. We can put the value of y and we can find the value of x. Or the easier method is simply substitute the value of x, that was 12, into the equation, into the linear equation, right? It's the equation of a straight line. Into the linear equation and find the value of y. So what would be the predicted value? We can say the equation was given as 0.386 minus 2.432. The predicted value of x was 12. They wanted to know for the age of 12, right? That means 0.386 into 12. It comes out to be 4.632 minus 2.432. And the answer comes out to be 2.2. But we need to round it off to the nearest integer. We do round down to, agreed? If we round it up to the nearest integer, it's rounded down and the answer is 2. Agreed? So the prediction says that for this game design, a 12-year-old will be able to win 2 games. Agreed? Please do try a few more questions, okay? We have a lot of examples done. And if there are any problems, just go through the video lesson again. Okay, best of luck. Have a nice day. Take care. Bye.